Hello, welcome back to SMR tutorial once again. In the last video, we had discussed about some basic problems on Fourier transform and inverse Fourier transform. So in this class, we are going to discuss some more problems on Fourier sine transform and Fourier cosine transform. So in connection with that, I'll take one simple problem here. You can see, find the Fourier sine and cosine transform of f of x equal to x where x lies between 0 to 2 and f of x equal to 0 in all other cases. So for this particular problem, we have to find out the Fourier sine and cosine transform both. So in the beginning class, we just given the formula for Fourier sine and cosine transform. So using that, we have to solve this problem. Very simple concept. Uh, we can easily solve this now. Okay. So let me start the solution. First, we have to write the Fourier sine transform and cosine transform definitions. Okay, so I'll write first Fourier sine transform. So the required Fourier sine transform. The required Fourier sine transform is given by. So what is sine transform? It is usually denoted by fs of u. Okay, s indicates sine transform. So fs of u is what? Integral 0 to infinity f of x into sine ux dx. So if we write this formula in the examination, when the question is based on Fourier sine transform, you will get 1 mark. So this is the definition of Fourier sine transform. Then here f of x is the function. So this f of x is what we have to find out. You can see the f of x value is x only for x lies between 0 to 2 and f of x value is 0 in all other cases. Therefore, f of x value we have to consider only x, because if I take 0 here, 0 into something 0. So that second function need not necessary. So only the first function x we have to consider in the interval 0 to 2. Okay, I'll just rewrite this equation 1 as per the given data. So what happens? So the function is defined in the interval 0 to 2. F of x in the interval 0 to 2 is x sine ux into dx. Then this we have to integrate by parts method. We already given in the previous video also. Now also I'll give. We know that integration by parts method, general method. Integration by parts, general method or Bernoulli's rule. What is that? U into V dx equal to U into V dx minus U dash into double V dx plus U double dash into triple integral V dx plus or minus etc. This is, see, when it is used, when we have, see, it is simple problem. When we have trigonometric function along with polynomial or exponential with along with polynomial, so normal integration by parts is not that much feasible. So this one, general method, is very much useful in this case. That is the reason we are using this. It reduces the most of the steps. So most of the steps. So I'll just rewrite using this integration. So I'm just applying this integration formula for this function. Here u is x and v is sine 2x. So this if we write, so what happens, we'll see. This is equal to first function u, that is x as it is, integral sine ux dx minus differentiation of x, that is differentiation of this function u dash, that is 1, we have to write. So double integration of sine ux dx plus, then one differentiation will be 0. If I write 0 here, 0 into something 0. So the problem will stop here. So between the limit what? 0 to 2. So this, if I simplify further, so what happens, it is x into x into integral of sine is minus cos. So that is minus cos ux by, what is coefficient of x? U. Minus 1 as it is. Double integration is there. Double integration of sine ux. One time integration of sine we already have, that is minus cos ux by u. This we have to integrate one more time. That's it. That indicates double integration. So what happens if I integrate this one more time? So cos becomes plus sine only. Therefore minus into plus minus only. Sine ux, we have one more u when we integrate the term double two times between the limit 0 to 2. Between the limit 0 to 2. So what happens if I simplify this further? That is minus x cos ux by u. Okay. So for this function you operate limit separately. Minus into, so you can see this minus into this minus become plus. So it is plus sine ux by u square between the limit 0 to 2. So here we have integrated the entire function with respect to x. So this u and 1 by u square acts as constant. We can keep them outside and we can operate limits for the remaining terms. So what happens? 1 by u minus, I'll write outside. So it is x cos ux 0 to 2 plus 1 by u square sin ux 0 to 2. So if I operate limit, so first function, this one, here all x terms are replaced by 2, all x terms are replaced by 0 here. You can see 2 cos 2u minus x value is 0, 0 into something 0. So what happens with simplification? First term 2 cos 2u minus 0 plus 1 by u square. Second term simplification 2 sine 2u sine 0, x is 0, sine 0 will be 0. So this becomes sine 2u minus 0. So therefore if I simplify and conclude this, u for this u and u square, LCM is u square. So if I write LCM as u square, and what happens since LCM is u square, one u will come in the numerator here. So that is minus 2 u cos 2u plus sine 2u. So if I rewrite once again by taking minus sign outside, so what happens it is, or if I rewrite the given term, so it is sine 2u minus 2u cos 2u divided by u square. So this is our required Fourier sine series. Okay. They're asking us to find out both sine and cosine transforms here. So first thing what we have done, we have operated Fourier sine series formula, Fourier sine transform formula. Then as per the problem data we have substituted f of x. Then we have operated integration by parts method. Then it is rest of all the things are only simplifications. Only simplifications. So now we got Fourier sine transform. So in the same way we have to find out Fourier cosine transform also. Well, just do that also. Fourier cosine transform. See, all the Fourier sine and cosine transforms are very simple when we have basic knowledge, basic integration knowledge, and if we remember the formula properly, then it is very easy concept. So most of the students will feel this concept as difficult only because it involves more integration. But integration is very simple concept. Only thing it requires integration. Okay. So let me start with Fourier cosine transform now. Fourier cosine transform. So Fourier, you can see here the required Fourier sine I have written. Instead of sine, I'll just write cosine transform is given by. So formula we have to write, that is Fc of u. Fourier sine transform is denoted by Fs of u. Fourier cosine transform is denoted by Fc of u. So Fc of u is what? Integral 0 to 2 x, or first you write f of x into cos ux dx. As usual in the previous Fourier sine transform, we have written f of x as x, because f of x value is x only in the interval 0 to 2, in all the cases is 0. That is the reason this f of x is replaced by what? X. So that is integral 0 to 2 x into cos ux dx. So again we have to operate the integration by parts method only. So that is x into integral of cos ux dx minus differentiation of x is what? 1 into double integration of cos. So that is 1 into double integration of cos ux dx. So what happens if we simplify this step further? So x as it is, integration of cos will be plus sine ux by coefficient of x is u, and this minus 1, and double integration of cos is here. See, one time integration of cos we have written here, sine ux by u, and this we have to integrate one more time, thus that is nothing but this double integration. Okay, so sine integration is what? Minus cos ux by u square between the limit 0 to 2. So if we simplify, what happens? Fc of u. So Fc of u equal to x into sine ux, just right here, x into sine ux by u. You can see here minus, and this minus become plus. Okay, so plus cos ux by u square between the limit what? 0 to 2. I'll operate separately that limits 0 to 2. So if we simplify that further again, so this 1 by u is constant in the first term because the limit is applicable only for x term. So 1 by u take it outside, here 1 by u square you take it outside. So what we left with, if I take 1 by u outside from the first term, it is x into sine ux between the limit 0 to 2, and here in the second step I'll take 1 by u square as common. So 1 by u square if I take common, so it is cos ux between the limit 0 to 2. So what happens if I simplify it further? 1 by u 2 times sine 2u minus 0, 1 by u square, and if you operate 2 for cos ux, 0 for cos ux, will have cos 2u minus cos 0. So if we simplify this further, it is 2 sine 2u by u plus cos 2u minus 1 by u square, because here cos 0 is 1, cos 2u as it is. So if we take u square as LCM, so the final answer, the final Fourier cosine transform is nothing but 2u sine 2u plus cos 2u minus 1 divided by u square. So this is our required Fourier cosine transform. Very simple. If we remember the formula for Fourier sine and cosine transform, this we can easily solve. Okay. So this is all about this particular problem solutions. I'll just move on to one more problem. Let me take one different type of the problem, like reduction part. The problem with reduction part. So I'll go with that one. See, for continuation of the videos, those who missed Fourier transform fundamentals video, kindly refer that. Then Fourier transform part 1 video also you can refer. Then this one is continuation of that. Okay. This is our second problem. You can see the problem. Solve the integral equation. Solve the integral equation. It is somehow little different application part. Solve the integral equation. Integral 0 to infinity f of theta into cos alpha theta d theta equal to 1 minus alpha, where alpha is between 0 to 1, and this integral value is 0 when alpha is greater than 1. Also, we have to evaluate integral 0 to infinity sin square t by t square dt value. Okay, so this is somehow little tricky but simple. We can easily do this. Okay, so I'll just take the solution part. See, what we have to do here, first we have to find out this f of theta value. Okay, this f of theta value we have to find out first. In earlier cases, the functions will be given like this. For this function, we are finding the Fourier sine sine transform, cosine transform, like that. Here, answer and question both have given, but the function is unknown here. The f of theta is unknown here, so we have to find out that unknown value first. Okay, so that we can do here. So I'll write first we have to find out the unknown value. So how to find out the unknown value? Usually, after integrating this answer, what we are getting in terms of u, but here the variable is alpha, so answer I am getting in terms of alpha. Therefore, you write here, see this after integration answer we are getting in terms of u usually. Fourier sine transform, Fourier cosine transform, in terms of u. Since the variable is alpha here, I am writing answer also in alpha. So f of alpha equals to, what is f of alpha? They have given f of alpha value is 1 minus alpha, where alpha lies between 0 and 1, and in all other cases alpha value is 0. Now, on comparison, or I'll just write f of theta formula. What is f of theta? That is 2 by pi integral 0 to infinity f of alpha cos alpha theta into d alpha. Okay, so why? Because this you can see here, it is with respect to cos only, therefore definitely it is Fourier cosine transform only. That is the reason, since that we are finding with respect f of theta unknown value, so we have to take the integration with respect to alpha, not with respect to theta. Now, so answer we know, f of alpha we know here, f of alpha is 1 minus alpha. Okay, for this particular interval 0 to 1. In all other cases is 0. That we have to substitute. So what happens, that is 2 by pi integral alpha equal to 0 to 1, 1 minus alpha cos alpha theta into d alpha. Okay, because we have to take only one. 0 to 1 it is 1 minus alpha, 1 to infinity it is 0. Alpha value 1 to infinity, greater than 1 the value is 0, so that you no need to write here, plus something into 0, 0 only, therefore no need to write that. Then this we have to integrate with respect to alpha as usual by parts method only. Here this is u, this is v, so we have to operate parts method. So what happens, it is 2 by pi integration by parts. If I consider first function, that is u, this is our u, this is our v. So u as it is, then integral of v, cos of alpha theta into d alpha minus differentiation of 1 minus alpha with respect to alpha is minus 1, because 1 differentiation 0 minus alpha with respect to alpha is 1, therefore minus 1, into double integration of cos alpha theta into d alpha between the limit 0 to 1. So then if we simplify this further, so what happens, 2 by pi, okay, so 1 minus alpha as it is, cos alpha theta integration is sine alpha theta divided by, with respect to alpha we are integrating, so theta is the coefficient, theta will come. And you can see here minus and this minus become plus. Double integration of cos. One time integration we have here sine alpha theta by theta. This we have to integrate one more time. Sine becomes minus cos. So that is minus cos alpha theta by theta square. Between the limit what? 0 to 1. So if we operate limit separately, so if I operate alpha value as 1 here, 1 minus 1 0, 0 into something 0. If I substitute lower limit alpha value is 0 here, it becomes sine 0, sine 0 is 0, 0 into something 0. So for both upper value, upper limit and lower limit, the first term is going to be 0. Easily we can tell that. So that is 0 minus 0 minus, because plus into minus minus, theta square I'll write outside, 1 by theta square cos alpha theta. So alpha value is 1 here, upper limit, therefore it is cos theta. Minus lower limit is 0, therefore cos 0 is 1. So if we simplify further, so what happens? This you can multiply 2 into minus 1 minus 2, because this is 0. Pi into theta square, pi theta square, that we have to write. So minus 2 divided by pi theta square cos theta minus 1, or if I rewrite, this is 2 by pi theta square 1 minus cos theta. By taking minus sign outside from this term, I can write like this. So this is half angle formula I can easily use. 1 minus cos theta is 2 sin square theta by 2. So that is 2 by pi theta square 1 minus cos theta can be written as 2 sin square theta by 2. So this is equal to 2 into 2. How much? It is 4 sin square theta by 2 divided by pi theta square. Now this is our f of alpha. Okay. So I'll just rewrite. This is our f of theta. Sorry, we got f of theta. So this f of theta, okay, I have to enter in the f of alpha value here. This we have to enter f of theta value. See, this is our f of theta. This I have to enter. So what happens? I'll just check. So integral 0 to infinity 4 sin square theta by 2 divided by pi theta square cos alpha theta equal to f of alpha. See, f of theta value we got. Here f of theta is there. I am substituting. Answer what it is, f of alpha, right? That is the reason f of alpha is written. So if I simplify it further, what happens? Integral 0 to infinity. I'll bring this 4 to denominator. It becomes theta by 4 or theta square by 4. That theta square by 4 we can write it as theta by 2 whole square. Okay. So and I'm shifting uh, this 4 to the right hand side. Sorry, 4 only I'm bringing to the denominator. This 5 I'll shifting to the right hand side. Okay. So what happens, that is sine square theta by 2 by theta by 2 whole square cos alpha theta into d theta equals to 5 into f of alpha. Okay, so this is our almost simplified form. This is d theta I forgotten. So this we have to simplify further, because they are asking us to evaluate this integral. This integral looks like sine square t by t square into dt. It is almost same. Sine square theta by 2, if I replace, it is t only. Sine square t by t square. But this cos alpha theta is not there in the result. So this cos alpha theta we have to eliminate. How to eliminate? By substitution method. Okay, by substitution method. I'll just take the substitution proper value for theta, then I'll reduce. So simply by looking at the problem, you can see theta by 2 is replaced by what? T. Okay, I'll take that substitution only. So I'll just erase this part for further simplification. So if we simplify further, put theta by 2 equal to t, then d theta by 2 equal to dt, then d theta equal to 2 times dt. Whenever we take substitution like this, we have to check the limits of the function also. The main intention of the substitution is what? We are converting this theta into another variable, that is t. At the same time, we have to convert the limits of theta in terms of limits of t. So what happens limits? You just check here. When theta is 0, t is also 0, because 0 by anything is 0 only. So when theta is infinity, t is also infinity. Why? Because infinity by something is infinity only. So t is also infinity. So t again varies from 0 to infinity only. Therefore, if I substitute all this, so what happens? It is integral 0 to infinity sine square t by t square. Theta by 2 is replaced by t. Theta by 2 is replaced by t. And cos alpha theta d theta is there. Alpha, that we have to write. So cos alpha theta is there. Theta is nothing but what? 2t. Okay, so that I'll write 2t. This is under function into d theta is there. D theta means what? 2 dt. This is outside the function. Don't merge both. So answer is this 5 into f of alpha. So if I simplify it further, integral 0 to infinity sine square t by t square into cos alpha 2t or 2 alpha t, and this 2 dt, what I'll do, I'll shift 2 to the right hand side, dt will be written as it is. So it is 5 by 2 f of alpha. So then if I take alpha equal to 0, because you see here this is almost near to this, but here sine square t by t square, that is there. This cos alpha is not there in the deduction. This I have to make it as 1. How to make it as 1? Only possibility is alpha as 1. Don't take t as 1. If you take t as 1, this may become cos 0, but this will become 0. 0 into something 0, I will not get this. Only option is alpha, I have to take 0. Okay, if I take alpha 0, This become cos 0, this will not change. So cos 0 is 1. And the f of alpha right hand side also we have to check. 0 where it lies between. So f of alpha means 0 lies between 0 to 1. So alpha value is 0, if I take 1 minus 0, 1. F of alpha is 1. So put alpha equal to 0. Then f of alpha, it becomes 1 minus 0 is 1. So therefore, finally we have integral 0 to t sine square t by t square into dt equal to pi by 2. So this is one of the important applications in mathematics, result in mathematics. This is how you can see without integrating this function we are evaluating the value of that integral. So this is the beauty of mathematics. This is the beauty of Fourier sine transform or cosine transform. Okay, so this is all about Fourier sine and cosine transform problems. I hope you guys enjoyed this session. Okay, so in the next class we'll meet with some more interesting problems on concept. Okay, so until that, thank you, take care, bye bye.